So I finally got this thing put together. Basically all I joined these were I put a bolt through a pre-existing hole into this wood and drove one of these threaded inserts, I think is what they're called. I got it from Rockler. Basically it has a 1/4 inch threaded portion inside, so this gets sunk into the wood, and then basically you can take this bolt in and out as much as you want, and it's not gonna rip the threads or the bolt out of the soft pine. And that way you can take this thing apart and put it back together if you ever have to move it, because it is pretty heavy. And then I did the same thing for the top and some pre-existing holes. But one thing I have run into is there's a slight bit of, it's hard to see, there's a slight bit of wobble that's occurring, and I think that's only going to get worse if I don't fix that. And the problem is that as this wobbles, this piece and the top aren't joined together, so these legs are just teeter-tottering on the bolts that are connecting them here and here and here and here. And so the whole thing just shifts back and forth. There's nothing stiffening it. So I think if I take something from here, attached to the top, not the side, down to here, then it should stiffen the whole thing up. So I got that extra piece of metal put in there. I decided not to go with the wood just for aesthetics reasons. You got a bunch of wood here, you got a bunch of wood here, and you only really have these sides and that little piece there that's metal, so I thought it would kind of tie things together a little bit better. The way I put this in, which is not put in exactly how I want it yet, it ended up being a little too long, so I'm going to chop this off, put another hole right here, screw a drywall screw in. This thing's gonna be painted black to match the cast iron. That actually went up and under, and just had 2 drywall screws put through it with pre-drilled holes, and now this thing is solid as a rock. That worked great. I also like the way it looks. It kind of brings back the original feel of having something in the middle, because it originally had, the treadle. And so on this table, it comes with these little cast iron little wheels on the bottom, and unfortunately on one of them it's missing. So I don't really have any metal that's this thickness, so I can't really make a metal wheel. Thought about doing wood, but the only problem with that is I believe that since this is such a small diameter of wheel, that with the weight on this fairly small axle is just going to break the wheel in half at some weak grain spot or something like that on the wheel. So what I think I'm going to do is actually 3D print a wheel to go in here, and I'll just do 100% infill. What I'm going to do is I'm just going to take my calipers and grab this measurement and go make a model. Okay, so I got the 3D printed wheel in here, and the way I attached it was just a number 8 bolt with two nuts jammed on the end. Put a little bit of black paint to blend that in, but this is the back side of the desk, and you'll never see these, and you'll hardly ever see that, and you'd have to be looking for it. The original way they did it was they just took a nail or rod, whatever you want to call it, put the bigger end, or put it all the way through and left the bigger end on one side, and then the smaller end they just hit it with a hammer until it was flattened out and would no longer go back through the hole. I just didn't do that for time reasons, and the hole was so large that it would have taken a lot to get it flat enough to not go back through. The factory wheel, I don't know why they did this, but the factory wheel has a ton of play in it. The inside diameter of this wheel is about twice as large as the axle diameter. I don't know what that's for. Maybe to reduce binding, but I feel like that would create binding. I'm not sure what that's about. I just went with the same size, so mine's extremely rigid. Rolls great, as it would considering these are steel wheels, but this probably will never get moved as far as with the wheels. It's going to be in carpet as well, so I don't know how much it's going to get moved. But as far as the strength of this goes, I know some people might be concerned with that. There's not a whole lot of force or weight on this at all, really. But regardless of that, this is about 80% filled, so it's almost completely solid plastic, and it's about 3/8 of an inch thick, and I believe it was almost 1.5 inches diameter. So there's a lot of plastic in there to keep that, hold that up. Alright, so I set up a simple jig to test the strength of the 3D printed wheel. Basically what I did was I got a piece of plywood and screwed all this together so that it doesn't lift up. But I have a car jack and just a standard scale here with the back wheels not where the force is being applied, but the back wheels in the center of the scale, and I zeroed that scale out. Then we will put something in here, or we'll put the wheel in there, and we will crank this up, and I'll put a camera in this tripod to be able to watch it. And basically, whenever it either breaks or I'm gonna say flattens out or bends, sorry about the noise, that'll be the breaking point or the point of when it's no longer any good. So the way I found out the mechanical advantage of this though was, first I weighed myself, which was 140 pounds. Then I put this scale, or then I put the jack on here, zeroed the jack out. Then I stood on the end of where the wheel will be put in, and I got 10 pounds of pressure on here, so we have a 1:14 ratio. So whatever this number is, whenever the wheel breaks, we will multiply by 14, and that will be the actual amount of force or pounds it took to break it. And right there it started to compress a little bit. It's actually digging into the wood. And there it goes. Alright, so unfortunately after testing this multiple times in several different ways, I was not able to get this to break. It consistently slipped out of the jig at 180 pounds on the scale. Basically, it would just compress, and then just slip out like that. One thing that was consistent though was at about 110 pounds there was a slight bit of deflection in the plastic. I would say at about 150 or so pounds it would start to bind on the axle. I think at that point there'd be enough deflection that it would squish on the axle and no longer roll. Now, because this was a 1:14 ratio, when I did the math, the compression started, meaning 110 pounds, started at 1,500 pounds of pressure, and the slipping point was an astonishing 2,500 pounds. Now, this isn't too crazy of numbers though, because if you look at ABS's tensile strength, it's 40 megapascals, and I believe that's about 5,800 psi that it takes to break plastic. Now granted, I would probably cut that number at least in half, or I don't know if in half, but at least a third of it, and only because the 3D printer is not 100%